Okay, this is the second half of the H12E exponential trigonometric motion video. And so we're going to start off with the problems here. Okay, so they've given the velocity vector, and at time equals 0, the particle is at the origin 0, 0. Find an expression for the particle for acceleration. So to find acceleration from velocity, I need to take the derivative of my velocity vector. Okay, so the derivative of 2e to the 2t power is going to give me 4e to the 2t power. The derivative of e to the 2t power is 2e to the 2t power, and the derivative of 2 is 0. It goes away. Find an expression for the displacement of t. Okay, so to figure out the displacement, now I need to take the antiderivative. I need to take the antiderivative of my velocity vector. Okay, so here's my velocity vector with the integral sign and the dt. So the antiderivative of 2e to the 2t is e to the 2t plus c1. And the antiderivative of e to the 2t plus 2 is 1 half e to the 2t plus 2t plus c2. And now I need to figure out what the c1 and the c2 constants are. So as it says, when time is 0, when time is 0, then we're going to have c1. We're going to try to figure it out. So we know that the position is 0, 0. So I'm replacing r with 0, 0, because that's my initial position. And I'm replacing t with 0. Okay, so e to the 0 plus c1, that equals 0. And 1 half e to the 0 plus 0 plus c2. So anything to the 0 is 1. So I've got 0 equals 1 plus c1, and 0 equals 1 half plus c2. So c1 is going to have to equal to -1, and c2 is going to have to equal to -1 half. Okay, so now that I've got c1 and c2, I've got my displacement vector, and I've replaced c1 and c2 with this. So basically, I just rewrote this guy here, and I replaced c1 and c2 with -1 and -1 half. Okay, question number 2. Okay, let's move this up. Okay, a particle has acceleration at time t given with this acceleration vector. The particle is initially at rest at the origin. Find an expression for its displacement at time t. Okay, so we're trying to figure out the velocity, and so I have to take the antiderivative of acceleration in order to give me my velocity vector. And so at when it's initially, it is at rest. So so we'll talk about that in a second. But the antiderivative of 10e to the 2t is 5e to the 2t. The antiderivative of -1 is -t. And then we have my c1 constant. The antiderivative of 4e to the 2t is 2e to the 2t. The antiderivative of 2 is 2t. And we've got our c2 constant. Okay, so at time equals 0, it is at rest. If something is at rest, it's got a velocity of 0. So I'm replacing this v value with 0 and 0 because it is resting. Okay, and Um, so I'm going to put in 0 in place of t, and then anything to the 0 power is 1. So I end up with um, 5 and 2, because e to the 0 is 1. And so now I know that C1 has to be negative 5, and C2 has to be equal to negative 2. Okay, so I'm going to take this velocity vector and replace C1 and C2 with negative 5 and negative 2. Okay, now we're trying to figure out um, uh, the displacement vector. So to figure out the displacement vector, I need to take the antiderivative of this answer. So if I take the antiderivative of this answer, we get this. It's set up to do my antiderivative. So, and it's at the origin. So if it's at the origin, I'm going to have this and this be 0. Okay? So the antiderivative of 5e to the 2t is 2.5e to the 2t. The antiderivative of negative t is negative 1/2 t squared. The antiderivative of negative 5 is negative 5t, and then plus c3. And then I have c4. Okay, there's my antiderivative. So now at the origin, we know t, we're going to plug in 0 in for t. And then we end up with C3 is negative 2.5 and C4 is negative 1. Hence, there is my displacement vector. Okay. Okay, this one is quite, it'll take us some time to explain, but that's okay. Alrighty, so we've got our acceleration vector right here. Given that the particle is the initial velocity is this, and the initial displacement is this, find an expression for the displacement vector. Okay, so first we have to take the antiderivative of the acceleration, and the antiderivative is going to give me my velocity vector. Okay, so the antiderivative of 8 cosine 2t, remember that the antiderivative of cosine is sine. The antiderivative of sine is negative cosine. So I'm going to get this, and the 2t, the 2 affects my antiderivative here. Okay, now we just said that the velocity is 0, negative 4. So I'm going to replace 0, negative 4 when the time is 0. And if I plug in 0 in place of t and put this value in for my velocity, now I can solve for c1 and c2. And as we said before, when sine is 0, we get 0. When cosine is 0, we get 1. So I'm going to replace sine 0 with 0. I'm going to replace cosine 0 with 1, and we get this. And in order for these to all be true, C1 has to be 0 and C2 has to be 0. So here is my velocity vector, with C1 and C2 being replaced with 0. Okay, we have to do this one more time in order to find our displacement vector now. Okay, so I got to take the antiderivative of this velocity vector, which you see here. And when I take the antiderivative, I'm going to end up with this. Okay, so now we're going to solve for C1, C3, and C4. And when time is 0, we know the initial displacement is negative 2, 0, right? So I'm going to replace r with -2, 0, because that's the displacement location when time is 0. I'm going to replace cosine 0 with 1. I'm going to replace sine 0 with 0. And so -2 times 1 gives me that. -2 times 0 gives me that. And you're going to see, in order for this to be true, C3 and C4 have to be 0. And there is my displacement vector for this equation, this problem. Okay, question B. Find the particle's displacement from the origin. Now, on the very first page, I think it was the first page, I don't remember where it was. Yes. Okay. The distance from the origin is the magnitude of the displacement vector. Okay. So, the distance from the origin is the magnitude of the displacement vector. So now we've got the displacement vector, which we just calculated down here. -2 cosine 2t, -2 sine 2t. So I'm going to find the magnitude of that. So take each of those values, square it, add them together, take the square root. -2 squared is here and here, so I can factor out the -2 squared. And then I'm left with parentheses cosine squared 2t plus sine squared 2t. And as we said before, using our trig identity table, trig identity, we know that this is equal to 1. And -2 squared is 4, and the square root of 4 is 2. That is the distance from the origin at time t. Okay. Hence, describe the path. The path is going to be a circle. The radius it's always going to be a distance from the origin of 2, no matter where you are on in time. Okay, since it doesn't have time, it was able to be factored out. Question D. Given that A equals KRT, state the value of K. Okay, so the magnitude of A, of this guy here, I take the square root of 8 cosine 2t squared plus 8 sine 2t quantity squared. I can factor out the 8 squared, and I'm left with cosine squared 2t plus sine squared 2t, and as we said before, that's equal to 1. And the square root of 8 squared is 8. So my value of A is 8. Okay. So we know A, and R we just found out was 2, didn't we? So if A equals KR, and if we know A is 8 and R is 2, then K has to be, divide both sides by 2, K has to be 2. Okay, one more question, yay! Okay. Okay. A particle moves such that displacement at time t is given with this. Find the expression for the velocity of the particle at time t. So to figure out the velocity, we need to take the derivative of our displacement location. So the derivative of e to the 2t is equal to 2e to the 2t, and the derivative of 3e to the 2t is 6e to the 2t. There is my velocity expression. Question B, find an expression for the acceleration. So I need to take the derivative of this velocity expression now, and the derivative of 2e to the 2t is 4e to the 2t, and the derivative of 6e to the 2t is 12e to the 2t. Question C, given that A equals KR, state the value of K. Okay, so first things first, I'm going to find the magnitude of A. Now, it looks very complicated, but we actually don't have to undo and solve everything. So here's what we're going to do. Square root of 4e to the 2t squared plus 12e to the 2t squared. That simplifies to 4 squared. I'm going to factor that out, and we're left with this term. We're left e to the 2t squared. So e to the power 4t. If I factor out 4 squared, we're left here in this term. We're left here with 3 squared and e to the 4t. Okay, this I can factor out 4 squared, and I'm going to be left with this. Now this green part, just hold your horses and just I'm going to leave it like that for now. Okay, so now I need to figure out the magnitude of my displacement vector. So my displacement vector is e to the 2t, 3e to the 2t. So I'm taking those values, I'm squaring them, adding them together, taking the square root to get my magnitude of the radius vector. Okay, and then so now I'm left with e to the 4t plus 3 squared e to the 4t and the square root of that. And notice, these green things are both the same. Oh my goodness. So if a equals kr, and if a is equal to this, and r is equal to this, well, guess what? K is going to have to equal to 4. And that's it.